of course. Okay, let me talk to the whole class, okay? It's almost 11:30. We have one student in our class, and like before, the plan is to record some of the geometry problems from this packet. And if I'm not mistaken, I have done up to problem 7. Maybe I skipped a couple and it's all highlighted or will be during our study guide when I publish your study guide. I know some of these problems were done before exam 1. I didn't give you those. We only covered fractions. It was done on purpose. Those of you are going to watch it later. So the plan is we'll see what our student who's here wants to do. We'll start with that. Then we're going to do some of the problems and everything will be recorded. Again, I record for about an hour. And then I leave the last part as office hour, because when we just record and we don't have a lot of students, we don't get a lot of questions. So I can record a lot. So in class, people would say, do it again or show us an example. That's why. And one more reason, I do sometime, if it's a difficult problem, I generally do record a couple of versions, but you can always tell me, can you explain it again? You can always show up, ask me to do something. So I'm going to start with Brianna. Brianna, what do you think? What do you want to do? Do you have any questions about anything generic? I can't show you your exam here, but anything generic, I'll start with you. Go ahead.
I know there was one question on the test. It was the
What you're saying is breaking off. I can hear bits and pieces.
trying to remember one of the questions that was on the test.
What
This one
about
we had to make Alex, Betty, and Chris.
Yes. What happened? What about that problem?
Like the same answer as like I got the same as what they started with as they finished with.
That's
like
probably, yeah. I'm still, your statement is breaking off, but let me summarize what about that problem. Okay, two things. If you got the same thing, you're probably right. And I am going to open the exam for everyone after class today. You will be able to see your answer and my answer. And again, I'm talking to the whole class. If you see you're right, you wrote 0.5, my answer is half, I didn't give you, you can always email me and say, you know, could you look at my number 5? I will be happy to fix it. No big deal. Another thing, if the answer is 12 for each kid and you write 12, I understand, I'll give you points. If the answer happens to be the same as what they started with, that can happen. There's nothing wrong with it. If it's right, you're going to see it. If you want help with a very specific problem, and again, I'm talking to everybody. If you come to my come to class, make sure you take a screenshot of your problem. I don't want to open your quiz here in front of everyone. Take a screenshot, email it to me. I will retrieve it and do it for you. Does that somewhat answer your question, Brianna?
Yes, it does.
Wonderful. So if you want me to do, I'm starting with you. If you want me to do something from geometry or something from the past, that's fine. Or if you want to wait and look at your exam and then come back, that's also fine. Okay. So if we don't have any major questions, I will start working on number 8, number 9. They're going to get a little difficult. I'm going to warn you guys. Okay. And just to let you know, all of you will be teachers. Many of these problems are taken from exams like SAT, GACE, GMAT. They're actually a little more challenging than what you get on GACE, but they're actually very good exercise, and you can use them even in your 8th grade class. You can use some of them, so that's why they're appropriate. That's why we're doing it. And the name of the course is Mathematical Reasoning. So there's not a lot of theory you need to know, but the problems are difficult. So, excuse me, I'm going to start with number 8. Number 8, let's read it. This is not a difficult, I don't think it's a very difficult problem. It's my personal opinion. It's similar to something we have done. I'm going to take this problem to my, give me 1 second. I'm going to take this problem to my page where I do my write-up, where I do the writing. So it'll make a little more sense and I can. And again, for everyone, any generic exam issue, email me and you will be able to see your exam. I know you can't see it yet. Another thing I'm going to mention while we are moving things around, guys, if the computer gives you a grade, don't panic, okay? Don't panic. It's probably wrong and it'll only go up, hopefully. All right. Some of you emailed me. That was wrong. It didn't do that bad. I know you didn't. Okay, let's work on this. I'm going to go very slowly. All right. The figure below is made of 5 squares of equal area. If the area of the figure is 20, okay, there are squares. They're not saying these are unit squares. These are just squares. So this is a square. This is a square. That's what they're saying. So there are 5 of them, and there are 5 of them. But the area of the whole shape, all the 5 blue squares, this should be like this, is 25. Anyway, it's not going to let me delete it, but I will do one thing. Just want to make sure. Okay, let me do one thing. All right. Okay, we're back. So again, all of this has an area of 20. You want to know the area of each square, and the area of each square has to be 20 divided by 5 squares, and you're going to get 4. That allows me to conclude that each blue square here is really 4 unit squares. You can call it a 2 by 2 square. That's totally fine. Or you can kind of, I know my drawing is a little poor, but I'm going to do it so that you can see it. So basically, each blue square is comprised of 4 little unit squares. Now the rest is, excuse me, the rest is very easy. What's the perimeter of the figure? Well, count the edges. You can do it in 2 ways. You can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I will check my answer, but right now, let me draw this conclusion. Perimeter is 24 units. I'm pretty sure I'm correct, but I will check it. It's 24 units, and it's another way to do it. Instead of cutting it up, you know, each square is 2 units. Count the number. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 of them. Count it. They're all together 12 of them, and each is 2 units, and 12 times 2 is 24. So I will check my answer when I go to the other page, but now I'm going to pause there a little bit, see if people have any questions. All right. So number 8, hopefully is 24. Yes. And I have to fix it. It says inch squared, it really should be inch. Okay. So I'll fix that document. That's my job. Okay, you're going to soon see, guys, and I'm talking to everybody. Okay, you really want to understand these problems. I'm going to change some of the numbers, and some of them are going to be hard. Like, I think this one is one of them. Okay. All right. Now, I don't think this one is that bad, really. I don't think this one is that bad, but we're going to get to those today. And if you ever want to talk, all you have to do is unmute yourself and talk. Again, I am talking to the whole class. This is the area perimeter 1 packet from your book, from on BlazeView. There is a folder called problem sets. It's area and perimeter. So let's read the question, guys. In the figure, the large square is divided into 2 smaller squares and 2 shaded rectangles. If the perimeter of the 2 smaller squares are 8 and 10. Okay, remember guys, the perimeter is the perimeter of this square has to be the bigger one, 20. Okay, and the perimeter of this square has to be 8. This is the little one, and the 2 green shapes are rectangles. Now, rectangles have opposite sides are the same in any rectangle. So if the pink one is 20, you want to know the length of each side. This side is going to be 20 divided by 4 or 5. And this side is going to be 8 divided by 4 or 2. So take a look at this green rectangle, guys. I know 2 of the sides. I actually know everything. This side also has to be 5 because opposite sides are the same length. This side also has to be 2. So I know the lengths of the 4 sides of one green rectangle, but they want you to find the sum. What's the sum of the perimeters of the 2 green rectangle? Not a big deal. Okay, my answer is going to be, I'm going to find the perimeter of one green rectangle, but I need to know the sum. So I'm going to stick a 2 here. I'm going to find the perimeter of 1, which is 5 times 2 plus 2 times 2. 5 times 2 because 5 times 2 because there are 2 lengths that are 5 units long, and 2 times 2 because there are 2 lengths that are 2 units long. And why do we have this extra 2 here? Because there are 2 rectangles, there are 2 green rectangles. Now do a little bit of math. What you have inside is 10 plus 4 is 14 times 2, which is 24. And it should be, there are no units there. You can technically leave it alone, but it should be units if you have to put it. The answer is 24. This is number 9. Let me think about it a little bit. Sorry, it's not 24, it's 28. My bad. 14 times 2 is 28, not 24. That looks a little better. Let me double check my math, okay? That sounds about right, but I'll be happy to check my answer, and let's do it right now. Yeah, that's right. Pause it a little bit, see if people have any questions. And I don't think it's one of the worst ones. Now we're going to get into things that'll be a little tricky for some of you. And again, you can use it in your 8th grade class with your, strongest kids, and the easy ones for the whole class, some of the more challenging ones for the strongest students. All right, let's move on. Let's do one more. All right, I'm going to do 10. I'm going to save 11 for you guys. If you want me to do 11, you have to somehow communicate that to me. Okay, I'm not going to worry about 11. This is a little more challenging than the previous one, but not really too bad. So this is my number 10. And let's read it. Now, when I teach this problem in class, people do find it a little challenging, okay? So bear with me. Square ABCD is composed of one inner white square right here, and 4 colored or shaded congruent rectangles, and they're shaded yellow, red, blue, and green, the basic colors, right? If each colored or shaded rectangle has a perimeter of 12, okay? So let's do a little background work here. If I'm not looking at the picture, it's my rectangle. If this rectangle has a perimeter of 12, what is that supposed to mean? Well, that means this side plus this side plus this side plus this side is 12. All right. Now the catch is, I know these two sides are the same. We call them x and x, and these two sides are the same, y and y. So from that, using this argument, I can say, and this is a fancy term, it's called semi-perimeter. I know the semi-perimeter, that just this guy and this guy has to be 6. If the whole perimeter is 12, semi-perimeter is half of the whole perimeter, which has to be 6. I don't know what the width is. I don't know what the length is, but I do know length plus width is, this is a y, length plus width is 6. So all I know about these red, blue, and green and yellow rectangle, that they're the same. And this little x, this x, and this y is equal to 6. Is it 1 and 5? Is it 0.5 and 5.5? Is it 3 and 3? Clearly, it's not 3 and 3, but I don't know, and I can make those assumptions. I can't go by what it looks like. Okay, let's try it. Now, the argument that I'm going to use is as follows. Look at this green line. I'm going to try to do it nicely. This, well, unfortunately, it's too thin for my taste. Let's use this. Okay, this plus this is 6. Okay, here's the rub. Here's the rub. This guy is same as this guy. Why? Because the 4 triangles are congruent. That's why. So what I'm going to do, instead of saying this plus this is 6, I'm going to jump ahead and say this plus this is 6. You really want to pause there and reflect and make sure you do understand that. What's the area of the square ABCD? Again, square ABCD has the 4 rectangles and the white square inside, all of it. Well, now it's really not that bad. You can say the same thing about this. You can say the same thing about this side. It's basically a 6 by 6 square, or a square whose side it is 6 units. In a square, all sides are the same, all angles are right angles. So what's the area? And they have units. So I'm going to just say 36 u squared. Again, you have to make that tiny connection that this length and this length are the same. If you have any question, just don't be shy, just ask. Does that make any sense, Brianna?
Yes, sir.
Awesome. Awesome. Moving on then. I know if you think I'm going too fast for you, just slow me down. I'm pretending it's an online class. I'm recording things, but if I'm going too fast for you, just have to say, could you repeat it again, or can you show me another way? All right, let's move on. All right, I'm not going to do it. This is actually fairly parallel, really. I don't think you'll have a lot of problem with this. And if you do, you just have to show up and say, hey, can you do that again? And if you show up during my office hours, I'll do it. And I'll ask you, do you want me to record it? Do you mind if I record it? Most people say no. And I will upload it. Everybody will have access to it. Let's try this one. let me see, we're working on 12. I'm going to save 13 for you. Okay, this is becoming a little more tricky. Okay. All right. Again, I say it all the time in every class, half the battle is understanding the question genuinely. I know these are basic structures like squares, rectangles, but still there are some subtle things you want to make sure you don't miss. The figure shows 4 squares with a common vertex. Vertex is a point, corner. There are 3 smaller congruent squares. They're pink. And there's a larger one. It's purple, blue, whatever you want to call it. I'll just call it purple. Each square touches the other squares along the edges. Yeah, I can see it. Sure. Nothing new. The perimeter of the largest square is 15. Okay, this is a little tricky. I don't know how to say it. This perimeter is 15. Fine. So each side has to be 15 over 2. I'm using my calculator. 15 over 4 is 3.75. And that's fine. Each side, if the whole perimeter is 15, you take 15 and divide it by, you take 15 and divide it by 4. I just used my calculator and you're going to get 3.75. That doesn't help me a whole lot as of now. And that's fine to know because I don't know what this little length is. I don't know. Okay. Now, of course, they give you the perimeter of the whole shape. The perimeter whole, by the perimeter of the whole shape, the shape is this. They mean this, 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 this. And you can't say, oh, that little thing, I'm going to ignore it. It's too small. No, you can't say that. You can't say, oh, it looks like it's about 0.25. You can't say that. Now, here's the trick that we will employ. All right. And we're going to claim that this length is one side of this pink square is same as this length, like a door. And this length is same as this length. Okay, this is same as this, and this is same as this. Why do I want to go outside? Okay, let me erase this. And I am going to write it like this. This piece this green piece, all of it, with the little extra patches, extra strips here and here. All of this green length, what I drew green, is or has to be 15, because that has to represent, or that has to be equal to the perimeter of the purple square. So I'm going to write 15 right here. And why? Because this guy, let me go back and do it here so that I can delete it. This guy matches this guy, and this guy matches this guy. And this picture gets really messy, so I'm going to get rid of these arrow. Oops. Seems like it doesn't like it, but that's okay. All right, now the rest of the things are easy. I use a different color. Let's use orange. All of this. I'm going to set up a nice clean equation. And you can use this kind of equation with your 8th graders. They will understand. I'm going to say I need to find the perimeter of each of the smaller squares. So I'm going to say this is X. And let's do it in orange. Why not? This is X. This is X. This is X. This is X. I'm leaving this part alone because that's 15. Now, I have a clean, nice, clean equation. The green pieces, the green rods plus the 2 orange rods together is the perimeter of the shape, which is 27. So I'm going to write as follows. 4x, that's X, plus x plus x plus x plus 15 must be 27. Okay. Now I'm going to solve for x, and your eighth graders should be able to handle an equation like this, really. And most of them will. If I'm not mistaken, this is 12, and x is 12 over 4, which turns out to be 3. So x is 3. Now don't get all excited and say I'm done. The question says find the, I'm not going to erase the yellow and green marks. I know they hide some of the text because it's going to erase my picture. Unfortunately, what it says is find the perimeter of each small square. Okay, let's do it. Can't even move that, but that's okay. The perimeter of each small square is going to be, if each side is 3, this is what they're really talking about. It's really a little square. This is a representation of the pink square. And they're really saying it's 3, 3, 3, 3. This is this. So what's the perimeter? I'm just going to write P, and it has to be 4 times 3, or 3 added 4 times, which would be 3 plus 3 plus 3 plus 3, which is 12. And the unit is centimeter, just centimeter. A little tricky, guys. It's very subtle. If you don't, I'm talking to the whole class, okay? You want to go home, I'm going to give you some problems. If you want, you can ask me. I'll try to find some extra problems and put it in additional problems during the class. You want to practice this. I can sit here and there's no point in recording the same problem 5 times, but you do have to practice. And if you still don't understand what I'm saying, you have to come to class and tell me, can you explain it again? Or, you know, come during my office hour, which is right after the class. And if these hours don't work for you, all you have to do is schedule an appointment. Generally, I'm free between 8 a.m. to 8 p.m. However, I have, of course, some classes. I will send you a Zoom link and I'll be happy to help you. I'm going to pause here a little bit to see if people have any questions. And it is a little hard, guys. I know that. In class, when I teach this, I'll give them some time to work on it, and some of them will struggle. Some people can do these things, and people can do them in multiple ways too. All right. So I'll do 2 things today. I'll make some extra problems like this, problems that I think are difficult, and I will open your exam. Do take a look at your exam. And if you feel like I can give you points somewhere where you got the answer right, I'll be happy to adjust those. All right, moving on. Now you're gonna try the next one on your own, and there will be some more problems like this. I'll find some. Let's try this. This is actually 14. I'm gonna do 14 in class, and it's being recorded. I'm gonna check again. Yes, and you're gonna try the next one. And I'm going to employ a very similar strategy. Let me see. Take my problem. All right, so here's my problem, number 14 from area perimeter 1. And what we're going to do, same kind of a deal. I need to know the perimeter of the large square 6. This large square has a perimeter of 6. When they say entire shape, they mean this. All of this. Okay. All right. Let me do one thing here. Let me do one more thing. So it's a bigger picture, right? Okay. So All right, it's the same problem, same picture. I like the size because it's more flexible. So I am going to, the square, I'm going to employ the same technique, guys. I am going to say this guy is same as this guy, and this guy is same as this guy. So I am going to say all of this orange piece added together has to be the perimeter of the blue square. Why am I going outside? Well, on purpose, because I'm going to compare it to the perimeter of the whole shape. That's why. So all of this is 6 because the perimeter of the blue square is 6 inches. The rest of them, I'm going to label them a different color, and I'm going to call them X. I'm going to call them X. And my only concern here are these guys. Okay, these guys, they're these little pieces. I don't know what they are. So there's not a whole lot I can do. That's why I want to use that little technique of doing the green one. I know I erased some of my writing, but I'm going to go back and redo it. Okay, so each side of the green, little green square, I'm going to call it X. And I'm going to take some time to label it X, 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 X. I know I have 2 here, real close to each other. I'm not going to write an X next to orange because that's included in this 6. I'm not going to write an X next to this orange line. That's included in my 6. And why am I doing it? Because of this little pesky little piece here. That's the whole thing. Now I have a nice clean equation I can work on. What is it? Well, how many X's are here? Let me go back and write it properly. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 X's. So 10X plus 6 equal to 16. This is 16. And we have to do a little bit of math. And this turns out to be 10x. Subtract 16 from both sides. That's going to give you 10. Nice and clean. X is equal to 10 over 10, excuse me, is equal to 1. Almost done. What do they want? Find the perimeter of each small square. Okay, each small square has a side that's 1 unit long. Let me change the color. That's the conclusion we drew right from here. If X is 1, think of this pink square. It's a pink square that's 1 inch on each edge. What is the perimeter of this pink square? Well, it better be 4. I'm going to write my answer here. Final answer has to be 4. What's the unit? Inches. Let's put inches. I will check my answer, but I'm going to, well, let's check my answer. I'm not going to delete any of that. Number 14, hopefully it is 4. And it is. Good. All right. I'm going to pause it just a little bit. Okay. All right, let's see what's coming up. Again, I know I'm doing a lot of problems in a sense, and I'm going to skip this guy. Okay, you're going to try it. And if you feel like it's not so clear what I've done, you have to come and talk to me and tell me to do one more. I can do the one you asked me. I can make up a problem. All those things are acceptable. And I'm talking to the whole class. Don't be shy. Okay, let's see what's going on. Now, this problem is actually, you might be interested. It's an old SAT problem, a real SAT problem. I don't think it's the one I took, but a little after my time. I mean, I won't be surprised if those of you who took it, you had something similar. It's a very, I've seen many versions of it. Let's put it that way. All right, let's bring it to my little Mathigon Polypad page. All right, guys. Okay, read the question very carefully. The large rectangle, when they say the large rectangle, they're talking about this guy. Okay, all right. Was constructed with 5 congruent smaller rectangles. Congruent means they're identical size, same size. You can put one on top of the other. That's what congruent means. They're saying this is congruent to this. These 5 rectangles are congruent. That means their lengths are the same, their widths are the same. Okay. The width of each rectangle is 15. The width is 15. So this is 15. That I know. Let me go back and do it using this. I like this pen, not that you care. This is 15. All this is 15. That's what the question says. Okay. Now, I know I can write a 15 here. I know I can. The catch is they want you to find the perimeter of the large rectangle. Okay, so let me grab a second picture. I know it's too big. Okay, of course, it's the same picture. I need a little extra room to explain it. That's why I'm doing it here. All right. It's identical, but magnified. So clearly the question says this is 15. This is 15. This is 15. This is 15. And this is 15. Why? Because width means the shorter edge of a rectangle. They want you to find the perimeter of the larger rectangle. In order to find the perimeter of the larger rectangle, you do need to know the length. Now, if this is 15 plus 15 plus 15, this has to be 45. And you have to make that connection. If two of them, now let's change the color to yellow. Oh, let's see, blue. If this plus this is 45, this blue piece has to be 45 over 2, which happens to be, your calculator will tell you 22.5. Yeah, you do run into decimals, and that's okay. Okay, just a length. Each length of the rectangle is 22.5. I'm going to come back and write it here. And now I'm done. I'm done. Take a look, okay? We are using the idea that the 3 widths are, each of the 3 widths is 15. 15 plus 15 plus 15 is 45. That makes this big side on the other side 45, because in a rectangle, opposite sides are the same length. But this other side, the long side, that's 45 units, can be cut up into 2 lengths. Each has to be 45 divided by 2, or 22.5. Now, I will need a little bit of room. I'm going to squeeze things in a little bit. I'm almost done with the problem.
A quick question.
Go ahead.
Did you put 2.5?
Thank you, thank you, thank you. That's why I like it when people are here. Yes, I appreciate that. Is that better?
Yes.
Awesome. Thank you for catching my error. My error has been caught. I appreciate that. Okay, so I'm going to find the rectangle's perimeter, and I'll try to do it very carefully. So now you can use a little bit of shortcut. You can say, well, the width of the rectangle is 37.5. 15 plus 22.5 is 37.5. And the length of the rectangle is clearly 45, doesn't matter which side you look at. So what's the perimeter of the rectangle? It's 2 times the length plus 2 times the width. So let me see. Let me see. So I'm going to do it in the bottom. I'm going to say the perimeter, which is my final answer, is equal to 37.5 plus 45. And excuse my decimal point, it almost looks like a circle, but if I don't do that, it's going to make too small. I'm going to multiply it by 2. Why? Because there are 2 lengths, 45 and 45 on the 2 sides. There are 2 widths, 37.5 and 37.5, top and bottom. And this is, I can do it in my head, but I'm not going to take that chance. 45 plus 37.5 is 82.5. It doesn't look so pretty. All right. And when you multiply, I think I can do it in my head. 165. And the unit is inches. Now I will check my answer, but give me 1 second. I'm getting 165. And I'm sorry about this. I don't know how to get rid of it. If anybody knows how to get rid of this thing, sometime in future, communicate with me. Okay, let me go back and check my answer. This is number 16 real quick. Well, I'm getting 65.65. Okay, fine. I got the right perimeter. Fine. The catch is they also want to find me the area, and we can do it. I'll do it right here. So this part is correct. Let's do the area. Area is very easy. How do you find the area of a rectangle? Length times width. So you're going to say area is equal to the length, which is 45, times the width, which is 37.5. And I'm going to use my calculator. 45 times 37.5. 1,687.5. And the answer should be inch squared. Answer should be inch squared. And this answer is correct. I vaguely remember seeing it. So I'm not off. So I'm going to pause here a little bit. See if we have any questions. It's a little bit of work and you want to practice. Again, if one edge of the little rectangle is given, you have to find the length of the other one. I'll be happy to do one more. I'll tell you why. Because on the exam, I can give you the length of the little green rectangle and ask you to find the width. So we'll do it. It's a hard problem. People struggle with it. And just to let you know, it's something you can do in your middle grade class. Doesn't involve fancy equations. And many of the things that show up on the SAT or ACT are challenging middle school problems. So you should expose them to some of those things. You know, not every single day, but once in a while they should be exposed. And it's really to kind of to excite the students, you know, and tell them it's an SAT problem. It's hard. It's going to take some time. All right, let me do another one. All right. Now you might say it's really identical. It's not. And we're going to soon find out. So I'm going to do number 17. Well, let me take this right here, just like this. All right, it looks parallel. It's not parallel, but the reason I'm doing it, guys, I'm talking to everybody so that you don't assume only the width will be given. I think here they're saying the length is 15. They're clearly saying that. They're saying the length is 15 this time. So read the question carefully. Okay, don't assume it's the width because that's what we did in class. Of course, we're doing both. So this time they're saying the length of the little green rectangle is 15. That's what they're saying. Let me bring the other picture. I like it big so that I can mess with it. All right, I know it's too big. let's see. Same argument, okay? However, this time, this is 15 plus 15. That means this is 30. This time I need to know the width. This is same as this, which is same as this. So I'm going to take my 30, divided into 3 equal parts. 30 divided by 3, I'm going to write it here, is 10. That allows me to 30 divided by 3 is 10. And that allows me to conclude this little guy is 10, and this is 15 from the question. This is 10 from what I did. This is 15 from the question. So now I have a rectangle. Let's redraw it, and I'm not going to draw it this big. Actually, it doesn't hurt because I can make things a little smaller if I need the room. So I'm going to draw a second picture. Not the exact same size, but you know it's the same rectangle. That's what I mean. Good enough for me. Okay, now I'm going to claim this is clearly 25, the width of this large green rectangle, and the length is 30. What's the perimeter? Well, the perimeter is length plus width times 2. I'm just going to write P. 2 times length plus the width, and 20 plus 30 is 55, and that turns out to be 110 inches. And I'm not going to forget to find the area this time. Area is also fairly easy, length times width. We have done that in this class and also in 3190, and you've done it in other classes. And if I'm not mistaken, this is 750 inch squared. I will check my answer. That's what I'm getting here. Take a look. 30 times 25 is 75. So let me check the answer. Okay, so this is 17, 110, and 750 is what I'm getting. That's right. All right, just a couple of minutes for you guys to, I know we don't have too many people, but we have one person. We're going to respect that person. And I'm going to let you see if you have any questions. All right, let's see if we can do 1 or 2 more problems. Okay, I try, basically sometimes I feel like I'm just talking to myself. So I'm going to do at least 2 more, and I don't want to record for an hour and a half. That's a little too much work for you guys too, actually. In class, we don't do this. Now, this is a little tricky, guys, okay? I'm going to do this one, and I'm going to see if I can upload some problems. And this is, if you're following these videos, this is one of my favorite problems. Actually, I did a lot of my favorite problems today. What's that supposed to mean? Well, that means you'll see them on the exam with different numbers. And this one is really tricky. I don't know why, but people find this fairly challenging. All right, guys, let's see. Number 18. Here we come. Okay, I know this. Let's read the question. The shape below is comprised of 5 congruent rectangles. So this is a rectangle, this is a rectangle. There are 5 of them, and they're congruent. You can cut it up, put one on top of the other. Then what else is going on here? Let's find out. The shape below is comprised of 5 congruent rectangles. The rectangles are touching one another as shown, okay? The perimeter of each rectangle is 17. Okay, the perimeter of each rectangle is 17 means this whole, if you add the four sides of this pink rectangle, which is really the blue rectangle, all the four sides added together will give you 17. Now, I'm not interested in all four sides. I'm going to tell you why. I'm only interested in these two sides. And just like before, this plus this, just these two sides, better be 17 divided by 2 because it's the semi-perimeter. And 17 divided by 2 is 8.5. Okay, so again, the perimeter of each rectangle is 17. The semi-perimeter is half of 17. So let's write it down nicely. Okay. $8.5. I'm not going to worry about the unit. I'll put it here, but I generally don't. I want to put the unit, the right unit. When I enter my answer. Okay, the semi-perimeter rectangle is 8.5. Where is 8.5 coming from? Well, 17 divided by 2. Now this is the hard part, guys. Okay, I am going to, well, I'm going to use multiple colors. This guy is 8.5 because it's half of my perimeter. So is this guy. 8.5, half of my perimeter. So is this guy. 8.5. And let's try yellow. So is this guy. All these pieces, the pink, green, blue, and yellow pieces are 8.5. What is the perimeter of the shape? I want to find the perimeter of the shape. Now what's missing, guys? Now this is the part that's hard, guys, okay? And you really want to see it. So this piece, let me change the color to pale purple. And you really want to see it. This piece, the purple piece plus this purple piece. I don't know, where's the middle, where's this middle blue rectangle? Is it closer to the left, closer to the right? I don't know. So that's why I cannot say anything conclusively, but I do know one thing, guys. These three purple pieces, well, let's do it once again. I didn't say anything wrong, but I'm just repeating myself. This purple piece, or these three purple pieces, and these three purple pieces, when you put them together, they form one purple rectangle that's just like the blue rectangle. Okay, and you have to see these 6 purple edges that are broken apart. This guy, this guy, this guy, this guy, this guy, this guy. It's simply the perimeter of one full rectangle. I'm going to write it very nicely. This is 17. And you really want to pause. Those of you are going to watch it later. You're going to pause the video and kind of say, well, why is he saying that? This and this together, not that each is 17. And one way to see it, if you slide it all the way, you're going to see, but it has to be that. So what's the perimeter of this shape? Let's do our little answer. And we're going to do it here. So, sorry, the perimeter of the shape. And let's write it nicely. By the shape, I mean the whole thing containing all the 5 rectangles is going to be your 17 coming from the purple. And you have the pink pieces, that's 8.5. And then I know I'll make the text bigger, okay? And the green piece is also 8.5. Well, let me make the text bigger right now. Give me 1 second. So the next piece, the yellow L, is also 8.5. The blue L on the right-hand side bottom is also 8.5. This accounts for all the edges of this blue shape, which is made with 5 congruent rectangles. 8.5 is the semi-perimeter, and there are 4 of them. And the purple pieces are not semi-perimeter, they are the whole perimeter. And I'm going to just use my calculator, okay? 8.5 times, I think it's going to be 17 times 3. I think it's 51. Of course, I'm going to check my answer. Answer, add it all up, you get 50. And the unit is going to be, it's a little hard, guys, okay? It's one thing to just watch somebody do it, but make sure you genuinely understand what it is we're doing. I'm going to pause here a little bit, and let me go ahead and check my answer, okay? Yeah, that's 51 centimeters. I got it right, but I'm not going to record anymore, but it's going to be my office hour from this point forward. Thank you for coming to class, Brianna. I will, if you don't mind, well, let's see if you have any questions. Do you have any questions, Brianna? You can always ask questions on behalf of your friends too, but it's not a big deal. I'm going to jump out of this session and the recording will be downloaded, but I'm going to come back quickly using the same link and I'll be available for you guys. Anyone can come in and talk. It's almost 12:30, not quite 12:25, and that's plenty of math for today. If you want to come back again, feel free to come back and we're going to chit chat about our class. Thank you. Bye.